The following presentation will be covering the 26,000 through 42,000 single split systems offered as both a cooling only and heat pump product. This will not include the 30,000 and 36,000 BTU wall-mounted models currently being offered as a cooling only or heat pump system. This presentation will cover the servicing and commissioning of the PACi products only. This would be model numbers ending in 1U6. Before the system is started up for the first time, the following items should have been completed. A nitrogen pressure test of all the flared connections up to at least 400 PSIG, an evacuation of the refrigerant tubing down to a minimum of 500 microns utilizing a micron gauge to measure the level of the vacuum achieved. Verify the total distance of the refrigerant tubing installed and make any refrigerant charge adjustments based on the refrigerant charging table referenced in the installation manual. Make sure both service valves are completely opened and back-seated. Select the cooling mode, which is indicated by the snowflake on the remote controller, and set the set point down to its lowest setting. There is a standard 3-minute delay before the outdoor unit will start. Allow the system to operate for a minimum of 15 minutes before referencing any pressures or temperatures. These systems operate at a 0 to 5 degree superheat and a 20 to 25 degree delta T across the indoor coil when properly charged. Anytime a refrigerant leak is repaired, the entire refrigerant charge should be removed and weighed back into the system according to the amount shown on the nameplate using virgin R410A refrigerant. The first time the system is powered on after installation, the indoor and outdoor unit must first complete an auto-addressing process. This auto-addressing process confirms that the indoor and outdoor unit are a match set and tests the DC communication signal going from the outdoor unit back to the indoor unit within the 18-2 stranded shielded wire. The auto-addressing process starts as soon as the system is powered. Make sure all switches or disconnects are in the on position. If the system fails to address, the LED lamps labeled as 1 and 2 on the outdoor unit's main control board will be blinking simultaneously. When the wired remote controller is utilized, there will be an RC1 displayed on the remote controller with an exclamation mark, also indicating an auto-addressing failure has occurred. In the event the system fails to auto-address the first time, there is a manual procedure which can be initiated from the outdoor unit's main control board. First, power off the outdoor unit and wait for all the LED lamps on the main control board to go off. Once the lights are off, restore the power back to the unit. Next, you will have to locate the black button labeled as A.ADD on the board. This button can be found in the lower right-hand corner of the board. Press and hold the button in for 7 to 8 seconds and then release. The LEDs 1 and 2 should now be alternating back and forth. Once the outdoor unit has established communications with the indoor unit, these 2 LEDs will go completely out. This procedure can take up to several minutes to complete. The 18-2 stranded shielded control wire should ohm out at around 100 ohms when checked at either the indoor or outdoor unit. If a system fails to address after several attempts, this wire should be checked and verified as good. This wire should also never be ran within the same conduit as the power supply wiring. The communication signal is a pulsating DC voltage which is less than 5 volts DC and can usually not be read with an electrical tester due to the rapid pulse rate being generated. The outdoor units are shipped with 2 gauge port fittings. However, the second gauge port attached to the 3/8 service valve will only be used for pressure testing and evacuating the system. This gauge port will not show the true high side pressure when operating in the cooling mode. This is due to the fact that the metering of the refrigerant takes place within the outdoor unit, not the evaporator. These systems are pre-charged from the factory for anywhere from 10 feet of refrigerant tubing all the way out to 100 feet. When exceeding 100 feet, add 0.43 ounces per foot. These heat pump outdoor models are not equipped to show the true suction pressure when operating in the heating mode. The 5/8 inch gauge access port will show the true discharge pressure when operating in the heating mode. Always weigh in the factory charge as shown on the nameplate of the outdoor unit after any repairs have been made to the refrigerant side of the system. All Panasonic heat pumps will energize the reversing valve in the heating mode. The following slides will show a visual reference of where to locate the actual error code and how to interpret these codes. Always refer to the Service Technical Manual for a full description of these error codes for the proper diagnostic procedures. The Service Technical Manual can be viewed and downloaded from the website address referenced below. The wired remote controller has the ability to display the actual error code on the display screen as the error code occurs. This allows the servicer to spend less time in troubleshooting the system. The wired remote controller also allows access to the indoor unit's main control board to view items such as alarm history, monitor temperatures, and be able to make changes to the factory program settings on the indoor unit. When utilizing the wireless remote controller, when an error code occurs, it will be displayed on the indicator receiver lamp assembly as shown in this slide. The indicator receiver lamp assembly receives the command from the remote controller and sends this command to the indoor unit's control board. There are 3 lamps used for the error code diagnostics: the green operation lamp, the amber timer lamp, and the red standby lamp. The error code is displayed by the sequence of these lamps, not the actual continuous number of blinks. These receiver assembly lamps can do one of 3 things: stay on solid, blink, or stay completely off. Based on the sequencing of these lamps, the error code can then be determined by referencing the error code listing found within the Service Technical Manual. This slide gives a general reference of the 5 different error codes which can occur and the general meaning of each error code. Always refer to the Service Technical Manual for all the detailed error code information. The following 2 slides are a full listing of all the error codes and their meanings. There are 2 columns to the far right. The first one shows how the error code would be displayed when utilizing the wired remote controller, and the second one shows the error codes when utilizing the wireless remote controller. As seen from this chart, the wired remote controller displays the exact error code where the wireless remote controller shows several possibilities, especially when dealing with E-type error codes. Displayed on this first slide are the E and L type alarms. This second slide shows the P, H, and F type error codes. As seen from this chart, these types of error codes would be due to a problem either within the indoor or outdoor unit, depending on the error code being displayed. This slide is an illustration of how the error codes would be interpreted from the outdoor unit's main control board. As mentioned earlier, error codes can be displayed from either the indoor unit's wired remote controller, at the indoor unit's receiver lamp assembly when a wireless remote controller is utilized, or through LEDs 1 and 2 on the outdoor unit's main control board. LEDs 1 and 2 should be completely off when the system is operating without any error codes. The LEDs 1 and 2 located on the outdoor unit's main control board when blinking or on solid represent an error code hasn't occurred. When the 2 lamps are blinking simultaneously, an auto address failure has occurred. The exact error code can be shown by the number of times each lamp blinks. LED number 1 can blink either 2 times for a P alarm, 3 times H alarm, 4 times for an E alarm, 5 times for an F alarm, or 6 times for an L alarm. After counting the blinks on LED 1, then count the consecutive number of blinks on LED 2 to determine the error code. For example, if LED 1 was blinking 2 times and LED 2 was blinking 4 times, this would represent a P04 error code. When there is no operation on either the indoor or outdoor unit, check for 208/230 volts AC at the outdoor unit and the indoor unit's power supply terminals 1 and 2. Also, verify the fuses on the indoor and outdoor unit's main control boards are good. If the boards are being powered properly, there will be a solid LED lit on the control boards. Also, check for the error codes on either the indoor or outdoor unit. When replacing the main control board on the outdoor unit, the old EEPROM chip must be removed from the old board and installed into the replacement board. If this procedure is not followed, the system will not operate. These EEPROM chips are also directional and have an identifying mark on one side of the chip. Also, transfer any jumpers from the old board over to the new replacement board. Once incoming power and all the fuses have been verified electrically, next locate the reactor within the outdoor unit. This electrical component is located in the base pan of the condenser right below the condenser fan motor. Trace the 2 white wires back to the main board. Remove these wires from the board and check for continuity. A good reactor should show approximately 0.2 to 0.4 ohms. This value may vary some depending on the outdoor ambient temperature. If the reading is open, also check the electrical spade connections on the reactor itself to verify no corrosion has obscured this connection. If the wiring connections are good, then replace the reactor. When checking the winding resistance through the compressor, remove the red, white, and blue wire from the HIC board. The compressor will ohm out similar to a 3-phase motor and should have close to equal resistance between any 2 windings when conducting a continuity test. The winding resistance is generally 0.4 to 1 ohm between any 2 windings. This resistance may vary some depending on the outdoor ambient temperature. If no resistance is shown, check the compressor terminal connections at the compressor as well. When checking the HIC board, remove the red, white, and blue wires to the compressor and also the gray and yellow DC supply voltage wires. As reflected in this illustration, a reading of 200 k ohms or more should be present when checking from the positive and negative post back to terminals U, V, and W. Also, with power supplied to the system, there should be 280 volts DC or higher present across the HIC positive and HIC negative terminals. This tool, referenced as an inverter phase checker, can also be used to verify if the inverted signal from the HIC board to the compressor is good or not. This tool can be purchased through most HVAC supply houses. When checking the output from the HIC board to the compressor, first disconnect the red, white, and blue wire from the HIC board. Next, take the 3 wires from the inverter phase checker supplied with the tool and land each wire onto the U, V, and W terminals. It does not matter in which order these wires are landed. Next, restore the power and make sure the indoor unit is calling for either cooling or heating. There will be a 3-minute delay before the HIC board sends the signal to the compressor. Pay attention to the lights on the inverter phase checker tool. If the inverter outputs are good, then all 6 lights will turn on showing red, blue, and yellow. If there is a problem with the output board or the driver board which controls it, then 1 or more of these lights will not be lit. This is the contact information for one of the suppliers of this inverter phase checker tool. This tool is also available through other manufacturers. The filter board is fed with 208/230 volts AC of input power. There is a cartridge type fuse rated at 25 amps at 250 volts AC, which fuses one side of this incoming power supply. Always check this fuse to verify continuity or 0 volts across it if power is applied. The HIC positive and the HIC negative posts should show upwards of 280 volts DC when the system is being powered. These same posts can also be used to discharge the capacitors on this board once power has been disconnected. The CZ-RTC2 wired remote controller, when used along with the wiring harness part number 623-178-5082, can be utilized as a service maintenance tool. This allows the servicer to monitor both the indoor and outdoor unit thermistor temperatures, along with other details being reported back to the board. The alarm history can also be viewed and cleared from either the indoor or outdoor unit's main control boards. Changes can also be made to the factory programmed EEPROM chip settings. The current active alarm code can be read by plugging into either the indoor or outdoor unit's main control board for troubleshooting purposes. When replacing either the main control board on the indoor or outdoor units, make sure the factory installed EEPROM chip is removed from the old board and transferred over into the new replacement board. This chip is also directional and has a defined marking on one side of the chip as illustrated in this slide. Use care when removing or installing the EEPROM chip, as the pins can be broken or bent. A bent pin can be straightened back into place using care. Make sure all pins are seated properly into the socket on the board. This slide illustrates the half-moon notch on one end of the EEPROM chip and on the board socket. This marking on the EEPROM chip and the socket on the board should align when the chip is installed correctly. The system will fail to operate if the chip is installed backwards. This concludes this presentation, and thank you for your attendance. Please visit our Panasonic website for any additional information on our heating and air conditioning product offerings, along with our other great products.